This is mass to mass calculation in stoichiometry. But before watching this video, please watch everyday stoichiometry, mole A to mole B stoichiometry, and mass to mole and mole to mass calculation. If you do not watch these two videos, you will not understand this one. Endeavor to watch them. Okay, let's start with an example. Nitrogen and hydrogen react to form ammonia gas according to the following equation. Then this is balanced equation. If 56.0 grams of nitrogen are used up by the reaction, how many grams of ammonia will be produced? Okay, let's start with this example. So let's look at this example. We are going from grams of nitrogen to grams of ammonia. We are using this balanced equation. Grams of nitrogen to grams of ammonia. So the first thing we do is to, because this is from one substance to a different substance, obviously we have to use more ratio. It's a stoichiometry problem, but we can't go from grams to grams. So what we do is to change grams of nitrogen to moles of nitrogen. So the equivalent statement is equivalent statement will be 1 mole equal to molar mass. So let's look at molar mass of nitrogen. 1 mole of nitrogen. Molar mass of nitrogen is 28.02 grams of nitrogen. So we put it in fraction form, which is conversion factor. Or 28.02 grams of nitrogen over 1 mole of nitrogen. We need molar mass of ammonia because the answer will be in grams. So, but we first of all, then there'll be more ratio going from mole of nitrogen to mole of ammonia. So the mole ratio will be mole of nitrogen to mole of ammonia. From this equation, it will be 1 mole of nitrogen over 2 moles of ammonia, or 2 moles of ammonia to 1 mole of nitrogen. We find the molar mass of ammonia. So that should be 1 mole of ammonia equal to 1 mole of ammonia equal to 17.04 grams of ammonia. So we put this in conversion factor. Or 17.04 grams of ammonia over 1 mole of ammonia. So we go from, we start, so we have our strategy. So we know this. Mind ourselves what you're doing. We know this. And we don't know how many moles of ammonia. So the strategy will be, we are going from grams of nitrogen to moles of nitrogen to moles of ammonia to grams of ammonia. So from mole to mole, this is mole ratio. That's the main stoichiometry, mole ratio here. So nitrogen, that is 1 mole of nitrogen equal to 28.02 grams of nitrogen. Then here, 1 mole of ammonia equal to 17.04 grams of ammonia. Now, we are solving for moles of ammonia. So I think I need a lot of space. So we start from here. So that is 56.0 grams of nitrogen over 1 times grams of nitrogen over, then we have mole of nitrogen. Okay, looking here, 28.02 grams, 1 mole. Then we go use mole ratio here. Mole of nitrogen, mole of NH3, mole of nitrogen, mole of NH3. This one, 1 mole, 2 moles of NH3, so 1 mole of nitrogen, then mole of NH3, mole of nitrogen. So 1 mole of nitrogen, 2 moles of NH3. Cross all of this out. What did I do here? Oh, I'm sorry. 17.04. I'm sorry. 17.04 gram. What did I do here? I messed up big time. So this is grams. Oh, this is grams of ammonia. Sorry. Grams of ammonia. I'm sorry. 17.04. Then 1 mole of ammonia. So let me rewrite this. I'm sorry. 0.0 grams of nitrogen over 1 times 1 mole of nitrogen over 28.02 grams of nitrogen times, okay, mole of nitrogen, then mole of ammonia using ratios. This is where I messed up. So mole of NH3, grams of NH3, 17.041. So hopefully it makes sense now. cross this out, cross this out, cross this out, cross this out. That will be equal to 56.0 times 2 times 17.04 grams ammonia all over 28.02, which is give us 68.1 gram of ammonia. Sorry for the mess up, okay? I hope it didn't confuse you. Okay? So that's the first example. So let's look at this practice question. Pause the video and do this. We've done a lot of similar questions, so by now you should be able to master it. This is practice question. Nitrogen and hydrogen react to form ammonia gas. According to the following equation, how many grams of hydrogen must react if the reaction needs to produce 63.5 grams of ammonia? Okay, so pause the video and try it. Remember, grab your stoichiometry steps from the previous video. That will help you a lot. So let's look at the practice question. Hopefully you did it. So we have to start by analyzing the question. We are going from grams of NH3 to grams of hydrogen. Grams of NH3 to grams of hydrogen. So we start with going from grams of, we are going from one substance to a different substance. Obviously, there's mole ratio here, but we can't go from gram to gram. We have to go to moles. Moles, as we know, is like a bridge. Okay, so equivalent statements, we have to convert NH3 to moles of NH3. So 1 mole equal to molar mass. So we have 1 mole of NH3 equal to 17.04 grams of NH3. That's the molar mass of NH3. So we put this in conversion factor. 17.04 grams NH3 or 17.04 grams NH3 over 1 mole of NH3. Now, when we get from mole of NH3, we have to go to mole of hydrogen. So we use mole ratio. So mole ratio will be between hydrogen and ammonia. So 3 moles of hydrogen over 2 moles of NH3 or 2 moles of NH3 over 3 moles of hydrogen. Okay. Now, then we go from mole of hydrogen to grams of hydrogen. That means molar mass of hydrogen will be 2.02 grams hydrogen. So we put it in another, that should give us that, or 2.02 grams hydrogen all over 1 mole of hydrogen. Okay. So now our strategy is we are going from grams of NH3 to moles of NH3 to moles of hydrogen to grams of hydrogen. So we have 1 mole, so 1 mole of NH3 equal to 17.04 grams of NH3. Here we need more ratio. Here we need 1 mole of hydrogen equal to 2.02 grams of hydrogen. Now, we want to set it up. So we want to find grams of hydrogen. Grams of hydrogen, not moles of hydrogen, grams of hydrogen. So we know we are given this NH3 over 1 times grams of NH3. We are going from grams to moles of NH3. Okay, we look here, which one? We are using the first one. So 17.04. Then we are going to we are using more ratio now. We are going from ammonia to hydrogen. So we look at the mole ratio, 3 moles of hydrogen, 2 moles of ammonia, times, then we are going to grams of hydrogen. That's mole of hydrogen to grams of hydrogen. So we look here, 2.02 grams over 1. So we cross out gram, mole of ammonia, mole of ammonia, mole of hydrogen, mole of hydrogen. Now it will be 63.5 times 3 times 2.02 grams of hydrogen all over 17.04 times 2. So that will give equal to 11.3 grams of hydrogen. Hopefully, you are able to get it correct. Okay, more practice questions. More practice questions. Aluminum metal reacts with zinc chloride to produce zinc metal and aluminum chloride. So this is the balanced equation. Now it says a mass of 45.0 grams of aluminum will react with how many grams of zinc chloride? Then what mass of aluminum chloride will be produced if 22.6 grams of zinc chloride are used up in the reaction? Then a mass of 24.0 grams of zinc chloride will react with how many grams of aluminum? Pause the video and do it. Pause the video. If you do not do this on your own, if you're not challenged, you never learn it. Okay? Persevere. Don't keep looking at the answer. Looking at the answer or looking at the video as to how it's solved without you doing it, you haven't learned it. Okay? Let's do the first one. So we know 45 grams of aluminum, but it says how many grams of zinc chloride? How many grams of zinc chloride? So we do the same thing. So this is equivalent statement. We start with that. Equivalent statement. So we are going from grams of aluminum to grams of zinc chloride. grams of aluminum to grams of zinc chloride. So we have to convert to mole. 1 mole equal to molar mass. That's the equivalent statement. So we have to find molar mass of aluminum is 26.98 from periodic table. Remember, all the elements, the atomic mass unit is equal to their molar mass. Okay, you have to understand that. We did that some time ago. 26.98 gram of aluminum or 26.98 gram of aluminum over 1 mole of aluminum. Now if we get it to moles, we have to go from moles of aluminum to mole of zinc chloride. So mole of aluminum to mole of zinc chloride. So we use mole ratio to do that. So aluminum and zinc, I mean, aluminum, did I say zinc chloride? Yeah. Zinc. We are going aluminum and zinc chloride, yes. Okay, zinc chloride. Okay. So, zinc chloride and aluminum. So 2 moles of aluminum all over 3 moles of zinc chloride or 3 moles of zinc chloride all over 2 moles of aluminum. Then this will get us to moles of zinc chloride. Now, we have to go to grams of zinc chloride, which will be 1 mole of zinc chloride equal to, the molar mass will be 136.29 grams of zinc chloride. So we put it in fraction form of the 136.29 grams of zinc chloride or 136.29 grams of zinc chloride over 1 mole of zinc chloride. Now, remember zinc chloride, we call it zinc chloride because it's an exception as one of the transition metals. It doesn't have multiple cations. So some people may be wondering, why is it not zinc 2? It's not zinc 2. Okay, so now what is the strategy? The strategy is going from grams of aluminum to mole of aluminum to mole of zinc chloride to grams of zinc chloride. Grams of zinc chloride, no space. So this will be 1 mole of aluminum equal to 26.98 grams of aluminum. This one will be mole ratio from mole to mole. This is repetitive, the same thing. Then this will be 1 mole of zinc chloride equal to 136.29 grams of zinc chloride, 136.29 grams of zinc chloride. Sorry, it's not, it's squeezed in there. So now we want to figure out grams of zinc chloride. So we start with grams of zinc chloride. We know 45.0 grams of aluminum all over 1. Then this is grams of aluminum, mole of aluminum, grams to mole, okay? This is 1 mole. This is 26.98, okay, times. Now, mole of aluminum. Then we're going from mole to mole. The mole of zinc chloride, mole to mole, mole zinc chloride, the mole ratio. Where is the mole ratio here? So that's 3:2, okay? 3 mole of zinc chloride, 3 mole of zinc chloride to 2 moles of aluminum times mole of zinc chloride, grams of zinc chloride. So which is here 136.29, 1 mole. So grams of aluminum cross out grams of aluminum, mole of aluminum cross out mole of aluminum, mole of zinc chloride cross out mole of zinc chloride. So this will be 45.0 times 3 times 136.29 grams of zinc chloride, all divided by 26. You know, this is molar mass of aluminum. I'm sorry. It's not easy to read. 26.98 times 2. So that will come out to be 341 grams of zinc chloride. Hopefully you got it right. If you didn't get the first one right, why don't you try the second one? Pause the video again and try the second one and third one. So this is the answer to B and C. Okay? I hope you learned something. Thank you.